This is Geometry, Unit 8, Day 5. We're writing equations of circles. This is Part B. We're writing equations of circles, and we're also going to be graphing. So here, we're starting out with the equation. We know that the original equation of a circle is x minus h squared plus y minus k quantity squared equals r squared. When we're looking at the equation, h equals 0, that's a horizontal translation. K equals 0, there's no value next to the y. And the r squared equals 25. The r, when you take the square root of 25, is 5. That'll tell us where our center is located and what the radius is. So we can plot the points that are all 5 units from the center point. We typically would plot those horizontally and vertically. Then draw in your circle the best you can. Come over here to the next question. We see that the h and the k are inside the parentheses. So the h value is 2, the k value is -1. The r squared equals 16, so the r equals 4. So we'll go to our h and k, which is the center of your circle, plot your point, and go 4 units for your radius. And complete your circle. H is going to be 0, k is going to equal -2, r squared is going to equal 1, and when you take the square root of 1, you get 1. So 0 right and left for h, and down 2 is your center point with a radius of 1 unit away from that center. Here, we're given a center point, which we'll call our h and k. We're given another point on the graph, which is our x and y. So, it's often good to start with a sketch. We have a center at 0. We have a point at 0, 4. So we have our circle that goes around the center. That is 4 units. This distance here would be 4, which is your radius. So we know what the radius is. We know what the center is. So we're ready to write our equation as x minus 0 squared plus y minus 0 squared equals your radius squared. X squared plus y squared equals 16. For our second question, we still have our center at hk. We have a point on the circle still called xy. It's a point that's on the circle. So let's make a quick sketch just to be sure we know what we're looking at. We have a center at 3, -3. A point that's -1, 2. So we have all the points that are equal distance around that center point. That's a circle. What we need to calculate is what is the radius. We can't count horizontally, we can't count vertically. Horizontally would be right and left, vertically would be up and down. Our point is off to the side. So for us to figure that out, we would need to use the distance formula. Or we could use our circle formula. The circle formula is essentially the distance formula. We have an x minus, and like an x2 minus x1, where h is an x value, and y2 minus y1, where the k is just a y value. And you're squaring those and adding them together. We just don't take the square root to figure out the radius by itself. We actually want the r squared value. So our x value is -1, minus, comes from a formula, h is 3, the y value is 2, the k value is -3, r squared. So this becomes -4 squared, 2 plus 3, two negatives make a positive, so we're going to get 16. 5 squared is 25, which this adds together to be 41. So now we know what the r squared is. You could take the square root and figure out what the r was, but when you write your equation, you actually need to know what the r squared value is. So we're going to say x minus 3, quantity squared, that's your h value, plus y minus a -3, which is a positive 3 squared, equals 41. That's the equation of the circle that contains our point of -1, 2, and has a center at 3, -3. Now, if we have a diameter at 1, 6, and at 5, -2, we're going to have a circle that goes around here. Our diameter, remember, contains the center point. I just don't know where it is. It's clearly not the origin. Well, if you have the diameter, the center point is found at the midpoint of the diameter. So take your endpoints and our midpoint formula. So we'll have x1, y1, x2, y2, plug in 1 plus 5 quantity squared, and 6 plus a -2 quantity squared. 6 divided by 2, 4 divided by 2, gives us 3, 2. That is our h, k. So now we know what the center is. We weren't told the center in the beginning, so we had to calculate the center first. Now we know the center, we're going to find out what the radius is. We can use either endpoint because both endpoints are on the circle. So I'm going to take my typical equation. I can use either point. So my x minus my h squared plus y minus my k squared equals r squared. So here we get -2 squared, 4 squared equals r squared. 4 plus 16, that gives us a value of 20. So r squared is 20. So now we're ready to write our equation of x minus 3, that's your h value, plus y minus 2, because that's your k value, squared, equals 20. Every equation, when you write a final equation, it has to have an x and y. Here again, we can make our sketch. We have -3, 4. We have 11, -8. We can make a circle out of that. So we need to find the midpoint. -3 minus 11 over 2, or -3 plus 11 over 2. 4 plus a -8 over 2. 8 over 2, -4 over 2 gives you 4, -2. That is your h and k. Now we're going to take either one of those points, doesn't matter which one, that's your x and y. So my x is -3 minus my h value plus y minus my k value. That equals my r squared. I still don't know what my radius squared value is. Negative 7 squared plus 6 squared equals r squared. So we're going to get 49 plus 36 equals r squared. So r squared equals 85. So our final equation is x minus 4 squared plus y plus 2 squared equals 85. This is our h and k. Remember, it's always the opposite of what this looks like. Two negatives make this look like a positive. X minus h is 4, so it's x minus 4. And then we calculated our radius squared. Here we're looking at this point, and we're checking to see if this point lies on that circle. This circle has an origin for the center is the origin, and it also has a point on it that is at 0, 2. So 0, 2. The question is 1 comma square root of 3 on the circle or not? If it's on the circle, it's going to have the same radius as this one. Well, this center is at 0, 0, and that's our HK, and it has a radius of 2. So we're going to do the same problem like we did above, and we're going to test to see if its radius is 2 or not. So this is our x and y. So x minus h plus y minus k equals our r squared. 1 squared plus the square root of 3 squared equals r squared. What happens when you square 1? 1 times 1 is 1. What happens when you square the square root of 3? Squaring the square root of 3, square a square root and you get what's inside. So you get a 3. So 4 equals r squared. Take the square root. And this radius is also 2. They have the same center. So we now know they're the same. Yes. 1 comma square root 3 is on the same circle as 0, 2 and a center of 0, 0. That describes the circle that this is on. We have meteorologists, and they track several storms by using a Doppler radar. If the center of the radar screen is the origin, and each ring is 10 miles further from the center, we're trying to figure out what the equation is of our last circle. Well, we know the center is at 0, 0. You always need to know the center of the circle if you're trying to write an equation of a circle. To figure out the radius, it's 10 miles to get to the first radius, 20 miles to get to the second, 30 and 40. So it's 4 times 10, which gives us 40. So we know our equation, since we have a center at 0, x minus 0 squared plus y minus 0 squared equals 40 squared. X squared plus y squared equals 1600. The plotted location of a cellular phone tower on a coordinate grid is negative 3, 2. So we should make a bit of a plot of that. Negative 3, 2 would be in this location, and it's 5 units out. It's sending a signal for 5 miles in every direction. The question is, where you live at 1, 5, is that in the circle or out of the circle? So what we need to do, we need to take this center of negative 3, 2 and that point and see if they have the same radius as 5. So this center is negative 3, 2. That's going to be the x, or the h and the k. And this radius is 5. So we're going to try to compare that with 5. We're going to take the point 1, 5. That's where you live. That's going to be our new x and y. So we're going to plug that in. So 1 minus a negative 3 squared plus 5 minus 2 squared. That equals our r squared. 1 plus 3 is 4 squared. 5 minus 2 is 3 squared. 16 plus 9, which is 25. So yes, when you take the square root of that, we get 5. They're the same. Yes, our house is on the circle. It's exactly 5 miles out. If the radius is 5, then it's the same as what this cellular phone tower can send. So now we're going to figure out about your friend's house at negative 6, 5. Where's that going to be located? So we're going to take a new negative 6, 5. Call that our new xy. So negative 6 minus a negative 3 and 5 minus 2, that equals our new r squared. Negative 6 plus 3, because 2 negatives make a positive. Negative 3 plus 3 is negative, or negative 6 plus 3 is negative 3. Squaring that is 9. And 9. So we have 18. So we're going to take our equation now, or what? Let's take a look. What were we doing with this r squared? We're comparing that with the r squared of the original. So the original r squared would have been 25. It would have been further. So this friend's house is inside the circle. It's less than 25. Less than 5 miles from the tower. So if you're less than 5 miles from the tower, then you're definitely in range of the 5-mile signal. Every 4th of July, Boston puts on a gala with the Boston Pops Orchestra, followed by a huge fireworks display. There's an explosion circle inside which all the fireworks will explode. Spectators sit outside a concentric safety circle. Concentric circles have the same center, but they have a different radius. In this case, it's a larger radius, and it makes the circle bigger, and it keeps people even further away. And that safety circle is 800 feet from the center of the fireworks display. So we know the circumference of the safety circle by calculating 2 pi r. We know that the radius is 800 feet because it comes from the center point to the edge of the safety circle. So 2 pi r, which is going to be 1600 pi, and then with our calculator we can say 1600 times pi. That's going to give us 5,026.55. That's how many feet around it would be. So if you had to put up caution tape, you would now know about how many square feet, or how many feet, not square feet, how many feet long you would need. If a safety circle is 200 feet, the safety, listen to that, the safety circle is 200 feet further from the center than the explosion circle. So the explosion circle's smaller, the safety circle's larger. Find the equation of the explosion circle. Well, we still know that the center is at 0, 0. That's h comma k. The radius is 200 less than the safety circle. So we subtract 200 from that, and we get 600. So now we're supposed to write an equation. Well, we know that the center is 0, 0, so that's when we come up with x squared minus y squared equals 600 squared. So x squared minus y squared equals 36 and 4 zeros. So 360,000. The organizers sprayed the ground inside the explosion circle. So think about which circle that is, the explosion circle that has a radius of 600. Each gallon that they spray covers 800, nope, it covers 8,000 feet. And it costs $50 for every 8,000s that it does. How much does it cost to protect the space? So, if we're supposed to spray it, it's feet squared, which is area. So we know that area equals pi r squared. We know that the radius of this is 600. So the area is going to equal pi 600 squared, which is 360,000 times pi. So we bring in our calculator, and we'll say 600 squared times pi gives us 1,136,973. 1,130,973.36, and these are feet squared. That's the square footage inside this explosion circle. So now we're going to take the 1 million and we're going to divide that up into 8,000 square feet groups. For each one of those groups, we're going to use one of these spray containers. So we're going to take that number and we're going to divide it by 8,000. So that gives us 141.37. We need quite a lot of these containers to spray the ground with. Maybe they should just use water. So anyway, if we have 141.37 and each one costs $50, okay, we could either take this value, you could probably round that up to 142 because you couldn't buy a partially sized one. Okay, but we're going to times that by $50 for every one of those. So we need to have about 7,068.58. to cover the cost that it takes to spray the ground. How much does it cost to protect the space? Over $7,000. Now, there's a small shed is located at the point 500 feet west, 225 feet north of the center. So if you're west, you're exactly sideways. North, you're up. So is it in danger? The question is it inside or outside of our explosion center? Explosion circle. Our center, of course, is at 0, 0 still, H comma K. Our radius we determined for explosion circle was 600. So we've got to do a calculation with this point and see if it also has a radius of 600. So we're going to take our x minus h squared plus y minus k squared equals r squared. So that's going to get us 550 minus 0 squared plus 225 minus 0 squared equals r squared. Using our calculator, we can see that 550 squared is 302,500. You can check that with your calculator. And 50,625. So that gives us an r squared of 353,125. That's our r squared. And we see that that's less than our radius squared. Our radius squared was 360,000. So it's close to the edge, but it's still within that same radius. So we can say not in a safe radius of our fireworks. Okay? You try to get a nice fancy spot to sit, and you're going to sit 700 feet to the east, 375 feet to the south. And the question, are you sitting outside of our concentric circles? Are you sitting outside the safety circle? So we're going to start out with x minus h quantity squared plus y minus k quantity squared equals r squared. So our point is 700 minus 0 squared plus 375 minus 0 squared. When you square 700, you get 490,000. Here you get 140,625. Now we're going to get 630,625. That is our r squared. And we can compare that. 800 squared would be 640,000. So yes, you are still inside the explosion circle. No, you're not in a safe spot. Where are you? You are inside the explosion circle. So, wait, you're inside the safety. Sorry about that. You're inside the safety circle, not the explosion circle. Remember, the explosion circle was 360. You're inside the safety circle, which isn't a good thing. You want to be outside the safety circle.